Welcome user to the new chapter. In this chapter we are going to see advanced CNN architectures, use of transfer learning and fine tuning. So let us start with first lesson of this chapter. In this lesson we are going to see different advanced CNN architectures. Advanced architectures are nothing but successful models with proven track record. This is most common in challenges like ImageNet, where the goal is to solve a real-life problems. For example, image identification with the data provided. Now let us see different architectures with their description. The first one we all can see, LeNet 5. Jan Luken and others suggested LeNet 5 as one of the first pre-trained models in the research article Gradient-Based Learning Applied to Document Recognition in 1998. The LeNet 5 is straightforward and it is composed of 5 weight layers. Out of 5, 3 are convolutional and 2 are fully connected layers. This is the architecture of LeNet 5. LeNet 5 was mainly designed for grayscale images. The input to this model is 32 into 32 grayscale image, hence the number of channel is 1. After that we are doing convolution operation with 5 into 5 filter size with 6 filters. As a result we have a 28 into 28 into 6 feature map. Following that, average pooling is used to minimize the size of the feature map by half. After that again convolution and pooling, and at the end fully connected networks are connected. We have already discussed how convolution and pooling operations would happen. This is all about simple LeNet 5 architecture. Has 3 convolution layers, 2 average pooling layers and 2 fully connected layers with softmax classifier. We were able to observe how LeNet operated. Only 10 classes with 1 channel image were used to train LeNet. As a result, LeNet is not powerful network for the multiple classes. After that, AlexNet was created with the goal of creating a deeper network capable of learning more complex functions. In 2012, AlexNet took first place in the ImageNet large-scale visual recognition challenge. Alex and his colleagues proposed the approach in a research paper titled ImageNet Classification with Deep Convolution Neural Network in 2012. There are 8 levels in the AlexNet, each with its own set of parameters that can be learned. The model consists of 5 layers with a combination of max pooling and convolution followed by 3 fully connected layers. They use ReLU activation in each of these layers except the output layer. They also employed dropout layers to avoid overfitting in their model. AlexNet is trained on 1000 object categories and it was very successful model till VGG has introduced. VGGNet was created in 2014 by Karen and Andrew of the Visual Geometry Group at Oxford University and hence the name VGG. Their publication Very Deep Convolutional Networks for Large-Scale Image Recognition introduced it. VGGNet construction blocks are identical to those of LeNet and AlexNet with the exception that it is deeper network with additional convolution, pooling and dense layers. VGG networks can be constructed in variety of ways, but the most common are VGG16 and VGG19. VGG16 is made up of 16 weight layers including 13 convolutional layers and 3 fully connected layers. One of the most significant disadvantage of the VGG16 network is it is a large network, which means that training its parameters takes longer time. This is all about VGG network. However, when we add additional layers to the neural network, it becomes more difficult to train and the model accuracy begins to saturate and eventually decrease. As a result, ResNet was developed to resolve this issue. The residual network is well-known deep learning model that was first described in the paper Deep Residual Learning for Image Recognition, published in 2015. And with the introduction of residual blocks, the challenge of training very deep network has been overcome. By skipping some of the connections from network, we are able to reduce trainable parameters, and this would be possible by using skip connections. Right here we all can see architecture of ResNet network. We have ResNet 18, ResNet 34, ResNet 50, ResNet 101, ResNet 110, ResNet 152, ResNet 164 and many more. So far we have seen how we can make deeper network to get more accuracy. But at some point, saturation will happen and accuracy will drop, and hence Inception network came to picture. Inception network has a different variants. Basic variant is also called as in GoogleNet. Inception network has been expanded wider rather than deeper. Presently, both ResNet and Inception networks are performing well for classification problems. This is all about different CNN architectures. To implement any of the discussed network in MATLAB, we have to install that network from add-on tag, and we can directly use that pre-trained network for specific tasks. In the next lesson, we will see how we can use the pre-trained network for classification task.
Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing.